and you guys go down the line and introduce yourselves, please.
Sure. Yeah. Good morning, everybody. My name is Monica Urisco. I am with AtkinsRealis, one of the consultants for the Georgia DNR, and I am a project manager. Nick, do you want to go ahead?
Hey, I'm Nick Turner. I'm also with AtkinsRealis, and I'm a GIS analyst.
Go to Lindsay.
Hi, my name is Lindsay Nixon. I am also with AtkinsRealis, and I am a GIS analyst as well.
And Matt.
Hey, good morning. I'm Matt Auk. I'm with AtkinsRealis, and I'm a water resources engineer.
Great. And I believe that's everybody who's going to be talking today. As we go through this is for your benefit. If you have questions, feel free to come off mute and just ask your question, interrupt us. That's absolutely fine. If you don't want to do that, you can type a question in the chat, and we will be looking, and we'll stop at some point and answer whatever questions you may have. So here's the agenda. Part one is about 1.5 hours, depending on participation. I'm going to go over the overview, and Nick is going to do a BLE website demonstration. Monica, you're taking over at part one?
Yeah, that's correct.
Okay, and part two is Matt, and part three is Lindsay. Did I get that correct?
Yes.
I apologize, everybody, if I don't seem like I know what's going on. But I've been fighting a cold, and I've been out a few days, so I'm a little bit behind on this, but I know the material well. Okay, Nick. So let's start with what is BLE. BLE is a watershed-wide modeling approach that we use to prepare broad and accurate floodplains. What it does is we use this data to do planning. So we'll do the engineering. We'll look and say, oh wow, the floodplains have changed a lot, based on our new LiDAR data and our new models. Therefore, we probably want to do a flood study down the road and redo your map. So that's the use. The other thing is we are doing modeling that provides BFEs, even for Zone A areas. So every flooding source on your maps is going to have a model, and it therefore is going to have BFEs. So you no longer have to go into a Zone A area and determine what your BFE is. You can just, and Nick will show you can use our web viewer and click on a spot, and it'll say BFE is this. And then you have your BFE. This stuff is done by my group, the Floodplain Management Unit. It has been through quality review. It has been through FEMA review. So it is absolutely fine and actually preferred by FEMA and the state if you use this data in Zone A areas. BLE does not, we don't redo models for Zone AE areas. That's because they're effective and you must use those. But for Zone A areas, which, let's face it, most of our floodplains are Zone A's, except in the larger cities, you can use that data. But there's also other things you can use this data for, and we'll get into those later, so I'm not going to talk about them too much, but you can use them for building floodplain management, general floodplain management. You can use it for mitigation. You can use it for, use the data to kind of analyze what goes into your hazard mitigation grants, that sort of thing. Okay, Nick. So why are we developing this? One, we just didn't have models for all of our flood zones, like I said, and we want to have a model. We think that's the only way you can get an accurate floodplain on your map. We feel that since the communities are asked to use BFEs for, development and doing LOMAs and things like that, looking at potential violations, it's critical just to give them the minimum, which would be the model, and the data that goes with that, the BFEs. So Since we do this on a mass watershed basis, we're able to do, it's a little more efficient for us. We can save lots of money, doing things like hydrology. We can do it for the whole watershed just instead of doing it piecemeal, stream by stream every, 10, 15 years, which is, this is a good way to get good data and not necessarily have good data you can use and not have to update the maps. Our goals is we had about 15,000 miles of areas that didn't have models, or the models were based on the old NED data, which you can see there at the top right. It's a course data. Each one of those little squares has an elevation tied to it, and that's what was used in the models to determine the BFE. That's not very accurate. Those squares don't really have a sense, but there may be a whole subdivision sitting in one of those squares, or a half a subdivision. So you're using one elevation for a very wide area. We have LiDAR, which you can see in the top left, and it has millions and millions of points, and it produces much better topography. We get to see areas where there's low-lying areas where water ponds. We can accurately determine which way the water's flowing. You can take a look at those pictures. I'm not going to go into it too terribly much, but compare the right side, which is the old stuff, to the left side. So looking at the middle one, the right side is kind of coarse. I mean, it looks good. You can see the stream channels and you can tell the hills, but it isn't much better than an old USGS topo map. But if you look at what the LiDAR picks up, you can see it picks up roads, stream channels, building lots, pads. You can actually see the building pads there and the areas that's been elevated, which gives much more accurate BFE data. Okay, Nick. This is the area where we started our BLE analysis. Why do we pick down there? Well, south of Georgia, maps tended to be older. It seems like in the past, the North Georgia with the Atlanta metro area, those 16 counties, they carried a lot of population. So they kind of got preference in map updates according to the goals that Congress set for the program. Want to reach out, spend our money hitting the biggest population we can. But we said, let's go south with the BLE. Let's go ahead and create this because there's so many zone A's. The data is, in some places, is just very inaccurate, as some of you know and have talked to us about. But you can see the stuff there in green. This is completed and up on our map viewer that Nick's going to show you. The stuff in blue is current. The engineering is complete and it's currently being uploaded to the map viewer as well. It's a lot of data, and it doesn't take hours to upload a watershed. It takes sometimes days to get all that data in there that Nick's going to show you in a little bit. But basically everything south of the fall line, we have created BLE data, and you can see that little area if any of you there from Tift County, Lee County, the Withlacoochee and little watersheds. It doesn't have BLE because we started redoing that watershed before the BLE, but we do have models for all that area as well, and it'll be up on our main viewer, which we can show you if you want to see where that is. Okay, Nick. We basically, the majority of this BLE was done using 2D methodology. If you kind of take a look at that map, those little streaks show the water flow. In a traditional 1D model, everything just flows from upstream to downstream. In a 2D model, because of how we use it, and I'll show you some pictures here in a second, we can tell if the flow is moving left, right, upstream, downstream, where it's going. It's dodging, housing, subdivisions, things like that. You get a really good representation of that combined with the LiDAR data. This is some information here on what we use. We basically use, I think, HEC-RAS 5 and 6 for most of this. We use, for those engineers out there, curve number loss method. We use NRCS soils data. We use land cover and impervious data from the NLCD 2016 data. The mesh size for the 2D model, again, if you don't, for engineers, is basically 250 by 250, but it's been refined in a lot of areas. Let's go to the next slide, Nick. I think that shows what I'm talking about. So on the left is what a raw 2D mesh is. It has a bunch of cells. And what the model does is that each one of those lines, it calculates what direction the water's flowing, the depth that it's flowing at, the velocity. So if this was a 1D model, it would just go from upstream to downstream and cross one cross section. But here you get 4 calculations for each grid cell. And a typical cross section might contain 10, 15, 20 cells. So you get a much better data. But what we do is we actually go back in, and you can see there in the left picture, the road goes through the middle of a couple of cells. Therefore, the model doesn't know that road's there, because again, it calculates at the grid line there. And since the road doesn't fall on the grid line in some of those places, it isn't calculated. So what we do is we go in and refine those cells, make them smaller, make sure a face goes across the top of the road. Then we know that the model's seeing the road. In the last cell there, we know there's a bridge there. So we're able to modify the model anymore by cutting through that road and showing that there is an opening there, and it allows the water to flow freely through there, as it should be, because it's a bridge, and it would actually make a more accurate BFE. Okay, Nick. 1D, I think, is what most folks are familiar with. We did use this in some areas where it made sense, although not too many, to be honest with you. I think we did it for one watershed. I don't remember exactly which one, but we'll show you it'll be apparent when Nick shows you the viewer. This is just standard. We put cross sections across the LiDAR. We use regression equations to develop the hydrology gauge data. If it existed, we'll do a statistical analysis on the gauge data to come up with our flows. And the thing to note is we do a drainage area up to 0.5 square, so a half a square mile. The difference with 2D being is we take it all the way up to the watershed boundary. But for 1D, that's not really necessary. After we have the engineering models done, this is what a map would look like for a county. It's a mess. Look at all that floodplain there. It should be horrifying to some of you. Basically, everything's a floodplain there, or I'd say at least half the county. You can see there's but we do, if we go to put these on a map, we do take a look at things like, well, what's the average depth? If the average depth is less than 1 foot and the drainage area is less than a square mile, we may not want to put that on the map. Traditionally, that wouldn't necessarily be on the map. So we can use these different categories in the conversation with you and say, well, this is what we got. This is our raw floodplain data. And then we can show you the different things that we can do. So we might just turn all those red areas to X shaded, so that you don't have to worry about that for floodplain management necessarily. Or we might just get rid of all the red and all the orange we keep, and we turn the yellow to X shaded. It'll be a discussion that we do with you. But the good thing is up on our viewer, it won't be effective. It won't be on your maps, but you'll be able to use it for floodplain management, and it should match what you see on the ground during storms. And it actually provides more information. So if you know a subdivision is going into one of those red areas, while there might not be a lot of water and there's no requirement to make them elevate or otherwise mitigate for new development in those areas, you may want to make sure they understand what's going on there. So it really helps that conversation. It helps you keep these new developments safe, that sort of thing. Okay, Nick? Oh, good. So at this point, I'm going to turn it over to the team, let them run through it. Again, come off, ask questions. As we'll be doing demos throughout, and as all you know, if we're doing a live demo up on our site or something, it may slow down, it may stop working, all those problems. But we'll do our best to muddle through any technical issues we have. But I'll turn it over to Nick.
Hey, thanks. Once again, I'm Nick Turner. I'm a GIS analyst with Atkins. Let's see. So I'm going to go over the Georgia BLE's homepage, website, and dashboard. So I have a few slides we'll go through real quick, just high-level overview, and then we'll jump over and do a demo of the website. Next slide. So Georgia's BLE website, it's kind of like a one-stop shop. It's one page, everything's located there centrally. It's easy to access all the information you need. We have the status viewer, which is going to let you know where the BLE is and where it's coming and where we have it posted. The dashboard, which is the map with all the data behind it and the reporting functionality. We have a playbook. We also have fact sheets, educational information, video tutorials. I'll show you all that good stuff in a moment. Next slide. So just a real quick sneak peek of the reporting functionality we have from the website. So you'll be able to click anywhere, click a building, click a point, and generate these reports with all the information and data from the BLE studies. All right, next slide. And we also have the BLE playbook. And so this is a PDF guidebook designed to help communities, gives them ways to leverage the BLE data with the effective. And then this workshop is kind of mimicking the playbook. So I'll show you that in a moment. And the setup and the headings will look real familiar to what we're going through today. And again, as Joe mentioned, these recordings will be all posted on the DNR's YouTube website, web link. All right, so I'm going to switch over real quick now for the demo of the website. So this is the website. So at the top, you'll see the three main links as I discussed. So we have the status viewer, the dashboard, and the playbook. So I'll come back to those in a moment. We have a real brief summary of what BLE is, and then a BLE fact sheet. So I'll click on that. That's a great two-pager handout, something easy to give to other officials maybe want to know more about BLE. Panning on down, there's lots of educational information, video tutorials. So a lot of what I'll show you today, how to generate reports with the dashboard. We have tutorials on that. All kinds of good educational information to let you know what's going on with BLE and what we have. So I'm going to go back up to the top. So the first one is the status viewer. So I'll click on that. And here you'll see a map of where we have BLE completed, and that's in the dark green. And then the light green, you'll see where the engineering is completed, and we are in the process of updating the BLE. So actually some of these areas in light green do have BLE already up there. As was mentioned, the areas on the west side have been up there a little longer, and we were able to build up some cache layers. So they'll actually run a little quicker now with all the data that's in the background. You know, it's a ton of data, and it can go a little slow. And so on the east side, those layers we're still working on building up some of the cache layers. So if you find they're running a little slow, maybe give it a week or so and come back, and hopefully it'll be running smoother for you. So I'm going to go back now, skip over the dashboard for a second. Let's look at the BLE playbook. So again, this is a PDF guidebook. really designed to help support communities, gives them ways to leverage this data, combine it with the effective and how to use it. And just, looking at this table of contents, this is really what we designed the workshop after to kind of mimic this outline. So it'll be a great resource to fall back on when you need to revisit some of this information. Okay, so now I'm going to click on the dashboard. So this is the map with all the data behind it and the reporting functionality. So at first you're going to have a disclaimer. We'll close that out, and you can see now all the BLE data where we have it and where it's populated. I'm going to zoom into an area. So real quick, some of the layers. So what you're seeing in this aqua blue color, that's your 1% BLE flooding. And your orange is your 0.2%. So you can see on this left side, we have a legend, and that'll be real helpful in understanding what you're seeing. Anytime you're confused or get a little lost, take a look at this legend. It'll help you out. It changes as you zoom in and out and different layers pop on or off, or as you turn them on and off, it's going to change. So yeah, keep an eye on that. So one thing to note, you'll have these dark masked areas. They highlight in red when you hang over them. So these are your effective detailed studies where you have AE detailed studies. As Joe mentioned, this is where you would not want to use your BLE data because you do have that detailed study. So we try to mask those out to steer you clear and point you back at the effective firms where you want to use in these areas. This hatching color, I'll circle back to that and we'll go over that, but that's what Joe was mentioning earlier, areas of 1% depth, less than a foot, and drainage area less than 1 square mile. So those are the areas, we might show we're showing as moderate risk now and not the high risk zone A. Looking over here on the top right, we have 5 icons. So I'll go through those real quick. The first one is your base map. So you can toggle on different base maps, imagery, we have roads, topographic, terrain. So a lot of times if you're trying to look at certain data layers, switch around the base map. It might help you help make certain layers pop off a little easier and be easier to see, display. If you're zoomed in looking at a certain structure, certainly the imagery would help a little more. So then we have each of these layers, each of these boxes will collapse. So I'm going to collapse that one back. The second one from the top is your search. So we can type in a city, we can type in an address, and this will help you find what location you're looking for here. I'll collapse that back. Next, we have an overview map. So this will keep you in line with where you are in Georgia. So as I pan around, you can see it moves around with me. So it's just a little overview map letting you know where you are in the state. And the next one, this is your layers list. So this is all the data on the website and what it's showing. So you'll see you have this eye icon. This lets you know it's visible. So let me zoom in. So you can toggle them on and off. And when it's crossed out, that layer's off. I'll give that one a minute to load here. Yeah, so there you can see the building. So the building are showing up as little house points, but that data was extracted from a building footprint. So it's not just the information behind it is not just the point, it is the full footprint. You see we have modeled stream name, we have the streams, the names, we have counties, firm pans, the effective firm panel, HUC areas, some general base map information. And then let's see, I'm going to turn on the effective. So as you see in this dark red, we have your effective flooding. So you can toggle that on and off and compare it to the BLE data, but we also have a effective to BLE layer. And I'm going to turn that one on. Let me turn off 1%, turn off the 2%. And now you can see this is our effective to BLE. So it's letting you know the differences between your BLE and your effective. So anything in red will be where the BLE added flood risk. Everything in green is no longer a high risk area. It wasn't effective and it's not any longer in the BLE, and then the gray stays the same. So if I toggle on this effective, you can see how it follows that gray, and then areas that are no longer on it in it will be green. So I'll toggle on BLE 1%. You can see, and then we also have a buildings layer that follows the same symbology. So anything green is an area where the building flood risk is decreasing, and red increasing. So real quick, I'm going to zoom out and come over here where there's a watershed that, how Joe was talking about 1D versus 2D. So you see this watershed to the top, that is a 1D, and it looks, a little bare compared to this watershed to the south, which is 2D. And then again, the differences are, 2D, we studied the whole watershed. So everywhere got flooding, and 1D, it's just going to be up to the 1 square mile drainage area. So to kind of combat that, we do have the BLE 1% floodplain moderate risk layer, and that's that hatching layer. So that's going to kind of hatch out areas where the depth is maybe less than 1 square foot or 1 foot depth, and then the square mileage drainage area is less than 1 square mile. So those areas, they can be shown as X shaded, and again, we'll have those discussions with the communities on how they want to portray. But you can see once those are kind of hatched out, it's going to look a little closer to what we did with the 1D. All right, let me find. So again, there's a ton of data on here. So if you find it running a little slow, what I like to do is turn off some of these layers till you get to where you want, and then turn them back on with what you need. I'll switch over. I have one back to where it was. So going back through these layers, next we have our grids. So I'm going to turn on our freeboard. Let me turn off the 2%. I'll turn off some of these other layers. And I'll give the freeboard a second to load. Freeboard is going to be your 1, 2 foot, and 3 foot freeboard. So it's going to show that. So maybe your community already has freeboard, and you can kind of look and see what it will look like with the BLE data, or maybe you're looking to add freeboard 1 or 2 foot, and you can kind of get an idea of what it's going to look like at each interval. There we go. So I had to zoom in a little bit. So that's freeboard. Let me let the legend should populate here in a second. I think screen sharing, it's going a little slower. I'll move on for now, but it'll show you on the legend as soon as it's done loading the 1, 2, and 3 foot color symbology. So I'll turn freeboard off. We also have our water surface elevation. So these don't look like much now, but during the reporting function, we will be extracting these values. So I'll show you that. Right now, they just look similar to the floodplain. Moving into your depth grids. So these do have a little more variation in them. So these are the depth of flooding at that event. So I have the 1% turned on. So it'll give you the value and depth of flooding for that 1% event. Next, we have our probability grids. So the first one is the probability over 30 years of flooding, which is your most common mortgage length. So this is a real good tool for homeowners to kind of portray the risk, let them know, hey, you're not just in a high risk area, you have 90% chance of flooding over 30 years. It hits home a little more when you can use probability to explain it. And again, so here's our annual chance flood probability. So this will be the chance in any given year that that location or structure would receive flooding. So I'm going to kind of reset some of these layers real quick. Turn this on, and then I'm gonna collapse this and show you we have this extract data. So this allows you to download any of the data I just went over, plus the DEM topo data that was used. So you can select draw a polygon, and then you're going to draw this over the area you wish to download the data for. You can select the outputs type, so you can get a database, a shapefile. Sorry, let's jump ahead. A CAD file, and then select which layers you want to download. So maybe you want the 1.2% floodplain, maybe you want some grids, 1% grid, or 1% water surface elevation grid, and then we'll hit extract data and download that data. All right, going back to the reporting function, let me find. So we have a structure here that has an increased risk. So the green would be decreased flood risk, and this red is increased. And you can see it's not quite touching, the point's not quite touching the floodplain, but again, that's because the data was extracted from the footprint, not the actual point. So I'm going to click on this structure, and you can click on a structure, you can click anywhere on the map, and you'll still get this same report functionality popping up. So this is our report. So at the top, you'll have address, lat long. On the left, you're going to have your BLE information, and on your right, you'll have your changes. So it's going to show you the difference between the BLE and the effective. Each of these have a layers list. You can turn on and off the layers you want to see. You have a base map change, so we'll change this one, change it to imagery, so we can really look at this building. They work together, they're synced up, so you move one, the other's going to move two. So panning down, we have the legend that's going to let you know all the data that's showing above it. Going down, you're going to have some more high-level data, such as the county, watershed. On the right side, you're going to have a little more information pulling from the grid. So you'll have that estimated BFE that Joe was talking about. So this is so all these BLE flooding is going to have a BFE. When you click anywhere you want, you'll grab that. So this is your BFE. You also have your lowest adjacent grade. So you can see this BFE 143.4 is higher than our lowest adjacent grade. So that puts it in the high risk, the 1% event high risk. And you can see it was in the effect of a low risk. So that's why it's showing as a flood risk increase. Below that, this is some of the data extracted from all the water surface elevation grids. So we have the 0.2%, 1%, 2%, 4%, 10%, and 20%. So it's going to give you the elevation at each of those events. You can see it's not in the 10 or 20%, so that's not going to populate. The very bottom is our probability grids. So the first one is your annual chance. So this structure has an 11% annual chance of flooding in any given year. So again, that's a pretty strong case to share with someone about the risk for their structure. And then you also have the chance over 30 years. So a 73.9% chance. That's a pretty good chance over the life of a average mortgage that structure will could flood. Back to the top, you have a option to print this out to a PDF. It does take a second, so I have one pulled up. So it's just basically a concise way of looking at the report. Some information about the zones, some notes about what everything means, and then got your symbology for the different layers and what they look like. There's a few extra icons up on the top. So zoom to, so say you get you pan away from your structure, you can click zoom to, it's going to go back to your point. BLE summary just regenerates this report. Loma View, Monica is actually going to go over this one in her section coming up, so I'm going to skip that. Right now, the effective risk takes you back to the DNR's main web page for showing effective and prelim data. So this is their flood risk snapshot for the property. So if there's a effective study or prelim study, it's going to give you all that information here. Some of the same, current flood zone, lowest adjacent grade, all that good information, all in a concise snapshot. And last one is this flood model download. So again, this takes you back to the DNR's main web page that houses all their effective and prelim data. So if you wanted to download a model, so I'm going to zoom in. So again, on the west side of Georgia, all these models, should be up there now. The east side, we're still working on the new ones that were just completed. If you can't find a model and you're looking for it, it's not on this website, feel free to reach out and let us know, and we'll help you get that. But I'm going to zoom in on the map. I'm going to find this icon here. It says flood model search. I'm going to click on that. And then you just draw a box around the stream you want. It's going to highlight in red and then give you this download option here. So you can, I'm going to pan out a second, select a few of these. So you can see a lot of these have the same model description download, and these would be the BLE models. So they are more than one stream, so they are quite large. So be prepared for that when you go downloading them. Coming back, so I think that's it for the website. I'll try to get back to the home page here. But yeah, so that's all, and I'm going to turn it back over to Monica.
All right, before I start the next section, are there any questions for Nick on the viewer? You can ask a question or put it on the chat, and we can go from there. All right, seems like we don't have any questions yet. Can you guys see my screen okay?
Yes.
Nikki? Okay, great, thank you. All right, so now moving on floodplain management. So before I start, just a little summary. You guys are used to having only your firm maps with what we're calling, what we refer to as effective data. The majority of the South counties have older studies with zone A's that don't have BFEs or elevations published. So now this BLE data set covers pretty much the entire southern portion. The data is becoming available through the BLE viewer, but it is a different data set than your effective. Your effective data set is not going away. That is still your regulatory floodplains. So I am going to try to explain how you can use these BLE data for floodplain management. But just wanted to just make sure that there's that difference. Currently, the DNR is starting to use the BLE data sets that were created using these studies, this 2D methodology, 1D methodology, to create new maps, new FEMA maps, new firm maps. So slowly, these BLE data will become your regulatory FEMA data set, but we're not there yet. We're in some areas we're starting to move into leveraging that BLE data into creating new FEMA maps. So just wanted to start there. All right. So how can you guys use your BLE data set for floodplain management? As Joe mentioned, BLE cannot replace zone AE. Wherever you have a zone AE, those elevations, those water surface elevations are the ones that you need to be using. However, in areas where you have zone A's, like on your firm maps, those zone A's, as I mentioned before, don't have elevations associated with them. So that's when the BLE comes in handy, because this new data set of BLE uh, actually does have water surface elevations pretty much everywhere for every single recurrence interval. So BLE can be used for the, to get elevations around those zone A areas. Also, it can be used in areas in your communities that do not have any special flood hazard areas SFHA shown on the firm maps. So you can actually go and check those areas where you don't have any floodplains currently. There may be some risk that was identified with the BLE. So this is where this data set is so great, and it has so many uses. So it can be used for floodplain management. It can be used for risk communication, and I'll go over those in a minute. All right, so starting with permitting, I think everybody here knows that the National Flood Insurance Program, M.A.P, requires communities to permit all development, review all proposed development, but also assure that the development activities will be built in a manner that will be reasonably safe from flooding. So, as mentioned before, the BLE can help us generate these water surface elevations that can guide new construction, substantial improvement, any repairs. With this data set, you guys can identify estimated BFEs, so BFEs elevations, but also if a developer or even the community wants to do a pre and post project analysis, the models are available, as Nick showed on the website. They're also being uploaded slowly. These models are really big. So if you need a model and cannot download it, please reach out. We will have our contacts at the end of this presentation. So you can contact the DNR, you can contact us, and we can help you find these models. So these 2D models, if you have engineering in-house, or if a developer wants to evaluate the impacts of a development, they can be used for that. Now, this BLE data can support also like a lot of enforcement activities, especially before the publication of any regulatory products based on this BLE. One layer that Nick showed is the freeboard layer. It is available in the map viewer, and this layer shows areas where an additional 1, 2, or 3 feet of flooding could happen. So if your ordinance includes freeboard requirements, this layer is going to be very, very useful for you. Also, like if you're inclined to add that to your ordinance, the tool is there for you to be able to find out who is or what areas are in those +1, +2, +3 feet of freeboard. The BLE data can also support planned unit development decisions, especially those that incentivize developers to avoid placing new parcels on areas that are at risk. So, here, like, you could identify parcels that maybe, it's not such a good idea to develop there. Also, open space preservation and general land use planning. You can identify those areas where maybe the firm map doesn't show them, but with the BLE, you can see that there's going to be a pretty wide floodplain there. So you can prioritize those areas for open space or, land acquisition. And last but not least, the critical facilities. you can identify those buildings or even the access to those critical facilities, and be able to plan around it. Now, continuing with better enforcement, there is the community rating system, or CRS, and I'm sure you guys are familiar with it. In Georgia, we have 54 communities that are part of the CRS system, and with that, like the NFIP program recognizes and encourages floodplain management activities that exceed the minimum NFIP standards. So as communities have more of these activities, they get more points, and you can see there on the table, the more points they have, the lower the class, and as you go higher in the scale, the reduction of the premium, the flood insurance premium, goes up. So obviously your community residents are going to be very grateful for any extra activities you do, because that gets reflected on the premium that they pay for their insurance. All right, so these BLE data can actually be used because it's above the currently effective data, so it can be used to have additional credit. And I believe Emily with the DNR is the person to contact when you want to look into these credits. All right, so this BLE is also great if you want to do some targeted outreach activities. So, I mean, you want to communicate the risk, and sometimes it's like difficult to know, like, who do I go talk to, who do I call, who do I send a letter. So we have we're going to be showing areas of newly identified risk. So on the first picture, you can see in blue is what the effective or zone A floodplain looks like. So, not too big, obviously around the main stream there. But the BLE identified a lot more areas that are at risk. And you can see here, like, there's all these buildings that are potentially at risk, but if by looking at the FEMA map, they're not gonna get the sense that they're at risk. So this is when you can target that outreach activity, just communicating that risk. Another feature with the BLE data is that the 500-year floodplain, or the 0.2% annual chance floodplain, is shown and is available. In the past, if you open like a FEMA map, a paper map, or go online and look at the map, around the zone A, there's nothing. There's just zone A, period. And that zone A represents a 100-year, or the 1% annual chance. So now around those areas, you also have the 500 years. So that can help communities that have anything related to that in their ordinance, so they can use that data set. And also, for example, like downstream of a high hazard dam, we are showing pretty much all the areas at risk. Note that the BLE does not take into account dam breach risk, but still, this is like, the dams here, and we're showing all this area that could be potentially at risk with a high floods. So that's another area where you can use your targeted outreach. All right, another great one. This is a very cool feature on the website, on the BLE viewer, is that now we have a functionality to support letter of map amendments, and leveraging the BLE data to create the elevation certificate. as I mentioned before, the BLE elevation can be used as best available information. So for example, if you have a property that it is on a FEMA Zone A, before it was difficult to determine that BFE. Now with the BLE, you just go on the website and click on the building and you can get all that information. In order to get that BFE, a community supported BFE letter may be required. So, just be aware of that the property owners may come to you guys to request that information. Also, you can obtain the lowest adjacent grade lag information from the LiDAR, and I'll talk a little bit more on the next slide. All right, so this is not specifically BLE related, but the LiDAR, or the terrain that we use to create the BLE is a really good source of information, and you could actually estimate the lag. The lag is the lowest adjacent grade for each property using the LiDAR information. There's two methodologies that we're using to estimate the lag. One, and it is using FEMA guidance to calculate it, is based on the LiDAR-based contours. And there's a methodology, and it kind of adds a little bit of a, adds a little bit of safety, factor of safety there. And I'll show you the differences of the lag that you get by using the contour method or straight LiDAR point data. So if you ever see two different lags in our lag values in our website, just know that there's two methods used to calculate it or to estimate it. In order to use LiDAR to estimate the lag, the quality of the LiDAR data needs to be quality level 3 or better. In general, the LiDAR for your area, South Georgia, it is pretty good, and it meets the quality level 3. Just a reminder, like LiDAR does not replace and is not better than a survey of the property. So for like the best information to get a lag would be using a survey. However, LiDAR is a pretty decent estimate and could be used to support a letter of map amendment. All right, so at this point, I am going to switch to the viewer and do a little bit of a demo showing you the LOMA report that we can create. So here, going into the viewer that Nick already showed us, I have identified an area somewhere here. And let me turn on the effective flow hazard area so we can see. So in this area, for example, you can see how the effective was a lot wider than what the new BLE floodplain is showing. So you see the difference there. So if we want to look at our buildings that could be affected, hold on, let's give it a second. There should be a building somewhere here showing up in a second. And we can go and estimate the elevation there. Okay, it's taking a minute, but all right. So here's a building, right? It is on the effective zone A, but it doesn't seem to be in any blue area. So we're going to click on it. It's going to take a second to come up with the window, but you can see here the areas that are hatched is what Nick was talking about. Areas that are moderate risk, they are still 1% annual chance, so meaning 100-year, but because they are not too deep, so less than 1 foot of depth, or their drainage area is smaller than 1 square mile, we have marked them as moderate risk. All right, so this takes a second. You can see here also like how back in the day when the firms or the studies were created for communities, you can see how that that one community has like a bigger, wider floodplain, and as soon as they cross the boundary, it becomes a little smaller. So with the BLE data is just one continuous data set, so you won't see any changes, drastic changes like that at community boundaries. So Nick showed us this, and for example, for this particular property, you know, you have your address. Here under the BLE summary, you have your estimated BFE of 348.4. That's the water surface elevation at the 100-year event. And the lowest adjacent grade is 350. So, you know, the area, the land touching that particular property is higher than the BFE. So that is the condition needed for a LOMA, letter of map amendment. If you go here on the LOMA view, you're going to have a lag that says 349. So a little different than the one we saw before. This one was calculated using the contours, because that is what FEMA is telling us to use for LOMAs. So if you or if your property owners see this discrepancy, I just wanted you to be aware of why there could be a difference. So here, this is information you would need for a LOMA. So you have your lag, you have your estimated BFE straight from the BLE data set. You have your LiDAR source datum. You have a link here linking to the location of the LiDAR, and you have the accuracy information. Quality level 2, which is better than quality level 3. So we're good there. You know, that LiDAR can be used for your lag. So you have your legend, and you will have some LOMA submittal instructions. So it's a pretty nice report for someone wanting to submit a LOMA that may not have the resources to pay for a survey of their house. You can even print a report. I'm not going to do it here because it's running a little slow for me this morning, but you can change this portrait landscape, hit here print, and it will create a PDF with all this information and instructions on how to submit a LOMA. All right, any questions so far? No? All right, so let me go back to the PowerPoint. All right. Now talking a little bit about insurance and the flood insurance rating. It is important to know that I already mentioned that the BLE analysis does not influence the flood insurance rates. BLE is considered non-regulatory unless the BLE gets, leveraged into new regulatory products. So not a lot of communities have, I don't think any community has those effective yet using BLE. Some are moving into that, and I believe the viewer will have a status on what projects are being advanced into, making these regulatory products. But Right now, they are not regulatory products. Um, Joe mentioned before that the data these can be used in the future. One thing to note is that there was a change on the rating system. It was called Risk Rating 2.0 that changed the way of how the rate for the insurance is calculated. The purchase requirement is still based on your effective MAPs, but the rate that people have to pay for their insurance is calculated based on different data sources. And we have some information there on the right, like the distance to the flooding source, the ground elevation, building replacement costs, things like that go into this calculation of the insurance premium rate. BLE is not part and does not influence the flood insurance rate. So just for your awareness and if you get questions about that. So the purchase requirement is still based on your Zone A regulatory firm, and the rates are based on all these different elements. Nobody really knows exactly how they go into the calculation, but that's what it's being used. And there's more information about this on the FEMA website. So if you need to go there or send your property owners for more information there. All right, and my last information here is related to model ordinances. As you consider using base level engineering analysis, it's important to review your local ordinance and to ensure that it is up to date and includes the necessary language that would allow the use of this BLE data set. So if you guys are using the state's model ordinance template, you already likely have this language that would allow you to use the BLE data sets in your ordinance. So for example, if you see language that says other supporting data, that is BLE. BLE can be other supporting data. Or you see language that says standard engineering analysis not yet incorporated in an FIS. That is your BLE data. Or any language related to elevation data available to obtain, review, and reasonably utilize. That language also can, the BLE can also meet that language. So if you have that on your ordinance, using this BLE is, automatic, like you can do that. However, if you want to revise your ordinance, the DNR staff could support you guys, and then again we will have contact information at the end of these presentations, so you can reach out to them and work on your ordinance or look at it and ask for advice if what you have so far is conductive or like just adopting this BLE as best available data where you have zone A's. Remember, and this is for where you have zone A's. When you have zone AEs, you cannot replace it with BLE elevation information. All right, and with that, I am done with the floodplain management section. Any questions so far? No? All right. So now moving on to the fun part. We have a question and a poll is going to pop up on your screens. Please go ahead and click on the buttons there. If for some reason that is not working for you, you can type the answer on the chat. So the question is, true or false? base level engineering BLE data can be used to replace Zone AE information on your effective flood insurance rate maps firms. True or false? And reminding that these following questions have to be answered for you guys to receive continuing education credits. All right, so it seems like we got it right. Everybody got it right. So it is false. BLE data cannot be used to replace Zone AE elevation.
All right, so moving into part 2. In the previous section, Monica talked about the uses of base level engineering data for community floodplain management, and that is the primary application it was designed for, but there's a lot more that you can do with this data. So in this section, we'll look at some other applications of BLE, and I think you'll see some real opportunities for ways you can leverage this data to add value to your community. And better yet, maybe it will even spark some creativity and inspire your own ideas. And I hope that you'll share this with your local community officials, developers, and engineers, so that throughout your community, when there's a question or a project, that this BLE dashboard's a go-to tool to help you make better informed decisions. So a few applications that I'll highlight are using BLE for planning and design. In planning, you can use it for zoning, land development, public works. In design, if you have developments in a floodplain, or some other applications would be dam breach modeling and some water infrastructure applications. Then in part 3, Lindsay will be going over applications for emergency management and for hazard mitigation. So as we go, just be thinking about who you know who could benefit from these tools and how you can share it with them. And also note that using BLE and the estimated base flood elevations isn't mandatory. This information is just available to help you make better informed decisions and to build more resilient infrastructure, minimize flood risk for your properties. And it also doesn't replace the standard engineering design process. It merely supplements it to give you some more high-level insight earlier on in a project cycle. So the first application we'll look at is zoning planning. So in the planning process, you're trying to make decisions about the best use of land in your community, and you're trying to avoid allowing for development that will cause problems down the road. But those decisions are only as good as the information that you're basing them on. So as we've talked about, if you're only looking at the MAP special flood hazard areas, you're not accounting for a lot of at-risk areas, and the BLE will help fill in the picture in those areas that previously lacked that data. So for example, the image on the left shows a property that's located outside the effective SFHA in a zone X. But when you overlay that property onto the 1% BLE floodplain mapping, you'll see that a significant portion of that falls within the floodplain. So there's so that property is at risk, and you may want to consider rezoning to mitigate some potential issues with developing that area. So if you share that with your zoning departments, they can evaluate the existing zoning maps and plan for updates that will help avoid areas with the known flood hazards, and then everyone will be better off. You can also guide strategic use of areas within the 1% floodplain. For example, you can designate areas for open space preservation, such as parks and green space and conservation areas. So that adds a lot of public benefit and preserves natural floodplain functions and prohibits development that could have other adverse impacts. Similarly, but at a smaller scale, you can use BLE for land development planning. So you can guide the developers and site engineers to help them make smarter decisions when it comes to planning out their site and to reduce the flood risk to any structures and generally just be a lot more economical with the designs. So if you're planning a proposed development on this property shown here on the top left, you see it's, again, located outside of a special flood hazard area. There's not any flood risk information that's available to the site and nothing to restrict the development. But if you overlay that with the BLE results, again, like the site and the proposed building are located within the floodplain, and that building would be at risk. And so having this information earlier on will help to maybe steer away from a certain area or plan for developing in a different part of the site. And another way that you can use that is by looking at the depth grids. And so, you know, maybe there's a certain reason they would want to build in a lower lying area of the site, but if it's deeper in the floodplain, then that's at higher risk. And so they could relocate higher and to a higher portion of the site, and that would you know, both reduce the flood risk and reduce the cost of elevating a structure to meet freeboard requirements. You can also use the BLE to support your public works planning and capital improvement projects. So I'm sure that you have, as all communities do, a lot of infrastructure that's aging, failing, or just doesn't have sufficient capacity for stormwater and flooding. And so there's more to do than you have resources to do it. So you want to obviously prioritize those projects to maximize the benefits relative to the cost you're spending on it. And so you can target projects that will have, you know, maybe a higher drainage area or higher, you know, more overtopping of the roadway over areas that are at lower risk. And we'll actually do a demo at the end of this section to show kind of a workflow for how you can approach that. So yeah, the BLE data also gives you a way to estimate the likelihood and the consequences of failure based on the flood depth and the frequency of overtopping. For example, these are two bridge crossings on the left, but one is overtopping by 4 feet of depth, and the other is overtopping by half a foot of depth. And so the likelihood of failure of that road being washed out is a lot more if you have a lot more water coming over the road. You can also look at what areas are being flooded. You know, is it just a low-lying wooded area that's undeveloped, or is there maybe a critical infrastructure like this water treatment plant or a neighborhood that's being impacted? And that will help you to evaluate the the impact and the benefit that could be caused by mitigating an infrastructure asset. Oops. Sorry about that. So, and not only can you look at where you have critical assets like police stations or hospitals or schools that are in a floodplain. You can also look at access to those areas so that the roads that you need to be open to get in or out of a facility remain clear during a flood. And so by identifying overtopped roads, you can maybe plan whether there are alternative access routes, or do you need to elevate an existing road to reduce that flood risk? Or maybe you can construct an access road so that there's a back way into a neighborhood during a flood event. And again, this BLE doesn't replace the standard engineering design process, but it gives you some information before that process starts to give you some high-level decisions. But there are ways you can use it in design. So if you have proposed development in a floodplain, you can use the BLE models for floodplain permitting if, again, those are Zone A and not Zone AE. If you have a detailed model that's effective, you'll need to use that. But as the best available data for Zone A, you can use a BLE model for creating the corrected effective and proposed models for a no-rise analysis. And if you refer to the BLE playbook, there's a step-by-step workflow for creating a 2D no-rise model for a project site. And it may be helpful to communicate earlier on to any engineer or developer in your community that may be using these models to just have consensus before you start that process, and they're aware of how to approach that. Another application is if you have dams in your community, you can use this to assist in dam breach and inundation modeling. So you know that the Georgia Safe Dams program requires that any dams have a breach analysis done to determine the failure hazard. If that dam falls within a certain criteria, then if it's deemed to be high hazard, they require an emergency action plan for the breach zone, so that in case to mitigate the potential for loss of life. So you'll need to consult with the Safe Dams engineering guidelines to look at the specific regulations, and then ensure compliance with the standards for the breach and inundation modeling. Now, to be clear, there weren't any dam breach scenarios that were run in these BLE models, and the inundation zones aren't shown within the viewer. But what you can do is download that 2D hydraulic model where it's available, and then use that as a base for building the dam breach model. So that 2D model includes the base LiDAR terrain, the 2D mesh with the break lines, Manning's N values. You can update the terrain with additional survey data for the site, and you can refine the mesh as needed. And then you'll calculate breach parameters, update the unsteady flow inputs and boundary conditions, and then rerun the model. And so all of the expertise for building and validating that breach model is still required, but what this BLE data does is it lets you start a couple steps ahead in the process. Another interesting way to apply this is to support sanitary sewer rehabilitation projects. So you may have problems with inflow and infiltration in your sewer system. And if you use the depth grids and floodplain boundaries, you can identify where there's manholes or other infrastructure, sewer infrastructure that's maybe at risk of inflow. And so that can help you plan out where maybe you need to raise a manhole or seal it. And by doing that, you can target those repairs, and that will help reduce burden on the wastewater treatment plant, which would lower your operational cost and extend the lifespan of your facilities. So yeah, there's a lot of different ways that you can use all of this, and you might have some others as well. So next, we'll just do a quick demonstration to show an example of using BLE for capital improvement planning. So let's say that you're trying to prioritize bridge and culvert replacement projects. You have a capital improvement budget, and so you want to target the roads that are at highest risk of flooding. So using BLE data and some additional GIS analysis, we can identify those areas. So first what we'll do is go to the web viewer and find an area of interest. So in this case, we're looking at Thomas County, and Nick showed how to download that data. We might take the streamlines, 1% floodplains, 1% flood depth grids. You could look at other depth grids if maybe you want to go more in depth and say what event is the structure overtopping at. But for now, we'll just keep it a little bit simple. So I've downloaded that data and brought it into a ArcMap. You can use ArcGIS Pro or QGIS, whatever you have available or prefer. It'll be a similar approach, but I've downloaded it as a geodatabase, and you can see the features within the study area. And so what our approach is going to be is we're going to find the point intersections of all these streamlines and the roads. Then those will represent the culverts and bridges. And then we'll extract the value from the depth grid to those points, and that will show whether a road is overtopping and what depth that flood is above the road. So you will need a road polylines data set. You may have this, but for your community, but if you don't, you can go to the GDOT website, and they have a download for their database. And they also have a dictionary for what the attributes in that data set are to help you decode that information. So this is what that data set looks like. And I've brought in the F system feature class, which is the functional class. So is it a local road? Is it principal arterial? Is it an interstate? And that will help us to rank and prioritize the crossings. As, we run that. So the first step we'll do is just to use the intersect tool, and you'll just bring in the lines for the streamlines and the roads, and this will create points wherever they cross. And I won't run this, but what that result is now we have a points data set. And next, I would recommend going through and looking at all of these points, because the point may or may not be aligned with the crown of the road, and so there will be some errors. And also, if you have bridges, those bridge decks are removed from the LiDAR, and so those won't show up in the terrain. find a better one here. So here I've gone through and I've just edited, like copied that layer and edited the point by dragging it to the high point of the road. And that will help you get better, more valuable results. And so once you have have your points where you want them, you can use extract values to points. And then this will, you bring in your point layer, your depth grid, and what that does is it calculates a field with the overtopping depth at each point. And so this ranges from 6.3 feet down to just a fraction of a foot. And then we have a lot of node data. So those roads are not overtopping. But we have about 40 roads that were potentially flooding. So now you can export that table to Excel. And that'll give you just a spreadsheet with that same data from the attribute table. And then if you have a spreadsheet with your prioritization analysis, you can copy the data in. And so what we're trying to do is, the depth of flooding is important, but it's not the only factor in determining like the priority. You also want to look at what's the traffic on the road, what is the functional class. A higher, more critical route will be weighted above, a minor side street. You also may want to consider whether there are alternate access or detour routes that are available. And you can develop a scheme that that works for you, but what I just kept it simple, and I ranked these according to the from highest to lowest depth, and then took the road classification and kind of inverted that so that the bigger roads, which have a lower number, are weighted higher, and then just took the product of those to come up with a score. And you can see that that score is a different ranking than based on the depth alone. So you can modify that however you want. This is just kind of an arbitrary example, but we can go back to the GIS and see so for example, this crossing happened to be the highest ranked cross out of the all of the overtopping roads, and that's clearly because it had the deepest overtopping. Here this one was overtopping by 1.5 feet, but it's a more major road, and so it was ranked higher. And you can go through and look at what roads are getting flagged and maybe modify your criteria if something's not really making sense. But yeah, this is a really valuable way to take all of the assets and like start to focus down on where's going to have the highest benefit to doing a project. So yeah, I hope that gives you an overview of some different ways you can use the BLE for your planning and design. With that, if there's any questions, or we can hand it over to Lindsay. All right, Lindsay, you want to start?
All right, I'll go
Thank
ahead
you.
and take over. So For part 3, we are going to look at how to use BLE data within emergency management. So once again, my name is Lindsay Nixon, and I am a GIS analyst with AtkinsRealis. So I do have a few screens set up, so if I'm looking away from the camera, that's why. So the first section related to emergency management, we want to determine, can BLE data be used for emergency management? And the answer is yes, it can be used throughout all of the stages of the emergency management cycle, before, during, and after. So beginning with the planning stages, it's first important to determine how can we use the data. And there are different stages that exist throughout the development of the hazard mitigation plan. And this is just a theoretical breakdown of the planning of the emergency management plan or the hazard mitigation plan that your community would develop. So we've broken it down into tasks, and we are going to look through the tasks that specifically can use the BLE data while you're updating your plan. So our first task that we want to take a look at is task 4. So the first things that we want to understand is how can BLE data be used within your community, and what can your community specifically do with the data? So what tools do we have available, and what capabilities does your community specifically have that can be supported while using BLE data? And the web viewer can be used to view and download the data for your community, and the BLE data can be used as the best available data or the effective data, depending on the location and what product would best benefit your needs or your community members' needs for the mitigation plan updates. So we are going to do a quick demo again, looking at the BLE viewer. Quickly switch screens. So Nick went through the overview of how to download data from the BLE viewer at the beginning of the presentation, but we are just going to quickly review just to make sure that everyone understands. So you'll first go to the BLE viewer. You can zoom in to the area that you are interested in downloading data from. I can tell it's lagging a little bit just because I'm sharing my screen, but you will just choose the polygon that you are interested in downloading, and then you can select which layers you are interested in extracting. This pop-up comes from the cloud right here, and you can download the BLE 1% floodplain, you can download county boundaries, whatever products you're interested in downloading, and then you'll hit extract data, and it will download a zip file with the layers that you are interested in downloading. So moving back to our presentation. So how can BLE data be used for hazard mitigation planning? What we're looking at here on the screen on the left is the current status of local hazard mitigation plans as of July of this year. And you can see that many of the counties have approved hazard mitigation plans, and some have approvable pending adoption, but there are a few that are expired. And so you can look and find your county and see what the status is of your current hazard mitigation plan. And on the right-hand side, we can see the watershed data that we have available, or the engineering is completed and it is being uploaded to the BLE dashboard. The green watersheds are completed and up, and the blue, the engineering is completed, but they are still being uploaded to the viewer. The next task that we want to look at within our hazard mitigation plan update is how to conduct a risk assessment. And so this is for communities to identify their flood risk, the location and magnitude, and what assets are vulnerable and their probability of flooding. So we can use the BLE products to determine risks such as the depth grid showing the vulnerability and the depth of flooding at specific structures like critical facilities or community lifelines. As you can see right here, they've got hospitals, police stations, and schoolhouses identified, but those are just some of the buildings that you can identify their risk with the depth grids and the BLE data. We can also use the BLE products to determine the risk along evacuation routes to help with pre-planning of updating routes depending on flood risk. And it can help with estimating loss of using the building data. And we can use the probability grids to identify areas that have a higher chance of flooding based on frequency. So now I'm going to do another demo, and I'm going to look at how we can use the BLE data from the viewer. So I've already downloaded quite a bit of data from the BLE viewer here. We have the buildings shown in yellow. This is an area in Thomasville, Georgia. And in the past, we've only had the data from the firm that showed whether or not you're in the floodplain or you're not in the floodplain. And so here we have the special flood hazard area, which is the effective data for the area. But if we bring in the BLE data, we can look at the specific areas that are being affected, and we can pull in the depth grids that show the specific depth of the water at certain buildings that we previously would not know with just the special flood hazard area. So you can bring in the 1%, which is the 100-year flood depth grids, and have the buildings, and you can click on a specific building, and what will pop up is your building and the depth of flooding at that specific building. So we'll see that this has a 0.6 feet risk of flooding, but if you click on a different area, the flood depth will be different. So that's 0.7 feet, and you can download this for whatever community you are interested in from the BLE viewer. We can also look at the annual chance of flooding. So this would be the risk of flooding in any given year in a percentage. And so at this specific building, the annual chance of flooding is 20%. Like I said, you can click around to other buildings. This is also 20. You can look at a building in a different area. This one is only 3% of flooding, but we can use this data to better understand who needs to be notified for communication and outreach events to members of your community so that you can focus your efforts on those with the highest risk. And we can also look at the probability of flooding over a 30-year period, which is the average time of a mortgage. So that's beneficial and helps individuals understand what their risk is when they are going to be moving into a home that is located in a specific area. So this building has a 99% chance of flooding over 30 years. Move back to the presentation. So the next step of the hazard mitigation plan we want to look at is task 6, which is developing a mitigation strategy. So let's take a look at how we can use BLE data to best find a mitigation plan. So BLE data can be used to inform resilient development, and we can use the BLE floodplains to indicate areas that might need potential structure removal or relocation. And we can also use the BLE water surface elevation and depth grids as a tool when looking at elevating or retrofitting structures and utilities. And this will just help you understand how high you would need to elevate a residential structure or a critical facility so that it is outside of the risk of flooding. So I'm going to do another demo where we will look at how we can do that. So like I said earlier, we have the buildings pulled in for the specific area, and we can download the ground elevation data from the BLE viewer, and then we can also download the water surface elevation for the 1%, which I have right here. And as we can see, this area above the special flood hazard area previously has no risk identified, but this is the 1% floodplain brought in by BLE data, and we can look at a specific building. This is the water surface elevation for the 1% floodplain. We can look at a specific building and see that, click on this building. This building, the ground elevation is 265 feet, but the BLE water surface elevation data at the 100-year floodplain shows us that the water will be 266 feet. So for this specific building, we would need to elevate by 1 foot so that it is outside of the risk of flooding during that event. And if you have a GIS department, there's a lot more information that you can gather while using this data, such as buildings that are located in the BLE floodplain. So we can look at the buildings. I'll show you. So quickly, I'll just have the buildings that are in this specific area, and then the special flood hazard area that we see here. This is the effective data that is currently available. So if we do a select by location, we can find that when using the previous data, there is only one building that has been identified as having a flood risk. However, if we use the BLE data, we can do an additional select by location, looking at the BLE 1% floodplain, and the risk has grown to 62 buildings being in the flooding. So just by using the BLE data, we're able to identify risk of 61 additional buildings that we previously would not have known. Okay. Going to switch back to presentation. So now we want to take a look at how we can create a safe and resilient community. So implementing the steps within the hazard mitigation plan, most communities have ideas of what they would like to do to create a more resilient community, but they might not have the funding available to implement them. And so there are many grant opportunities available through FEMA, such as FMA or HMGP, and these can help implement portions of the mitigation plans and projects through grant funding. But first, it's important to determine that you have a positive benefit cost ratio before submitting your grant. So we can use the 1% BLE data to utilize the pre-calculated benefit instead of using FEMA's BCA toolkit. So by using BLE data, if your structure is located in the 1% floodplain, which is shown right here, we have this building in the 1% floodplain, and the value of the structure is less than a certain amount that has been determined by FEMA. It is currently $365,000. If you meet both of the requirements, then it's determined to be cost beneficial. And so the use of BLE data is incredibly helpful in areas that do not have effective special flood hazard area data that you are interested in getting grant money for, so that you can mitigate to develop a more resilient community. back and do an additional demonstration. So how can we use the BLE data to develop more resilient planning? And so without the BLE floodplains, none of the structures shown here would be potentially able to qualify for these pre-calculated benefits. But the use of these products allows for more structures in the 1% to potentially become eligible for the pre-calculated benefits. So I'm going to show you how to extract the depths for the buildings in the 1% floodplain. So shown here, we have the BLE flood depth grid for the 100-year flood. And if you're interested in one specific structure, you can use the BLE viewer and click on your specific structure, and the flood risk will pop up similarly to this having 1 for the 100-year flood. You can see all of the potential events at that one structure. But if you are interested in determining the risk of multiple buildings at one time, you are able to use this tool, Zonal Statistics, as a table. And you'll want to first input your buildings that you're interested in, and then you will input the BLE flood depth grid of the 100-year flood. And we're going to want to look at the maximum statistic type because this will show the greatest risk of the depth in the area. So then you'll run that tool and it's going to output a table, and all of the buildings that you input will be grouped up with their specific flood depth, their specific maximum flood depth at their location. And so you can zoom in and look at these buildings to better understand their specific risk. And if you're interested in doing this for all events for multiple structures, you can rerun this tool as many times as you would want with all of the flooding events. And then you can join the tables like I've already done here to the buildings, and it will show the depth across all buildings for all of the events that you have run the tool for. So here we've got the 20%, 10%, 4%, 2%, 1%, and the 0.2% depths. Okay, I'm gonna move back to the presentation. So one of the other big pieces for hazard mitigation planning is community outreach. And so it is important to make this data available to the public, which it already is available on the BLE viewer. You can send that website link out to your community and they will be able to download the data easily. It is important that community members have access to this data, just ensuring that you have transparency and that you've built trust with your community members, as well as it maximizes opportunities for greater consensus and acceptance for mitigation projects. And we can also use the BLE data to help inform capital improvement planning decisions. The previously mentioned information falls within the preparedness section of the emergency management cycle, but now we're going to look at the disaster response section within emergency management. So within this phase, we can use BLE data to help local emergency managers and officials make sound decisions during an emergency event. So it's important that while you're using this data, you have someone in the room that understands what it is saying and how to interpret the information that is being presented. Part of the ways that you can use this for disaster response is before an event happens, you can use the depth grids to simulate potential storm events so that you can prepare for the response actions during an event. So you'll know roads that might be overtopped, or you might know specific structures that would need first response. Moving on to disaster recovery after an event, we can use BLE data to make sure that the community is more resilient for future events. So in the short term, we can use the BLE data to identify areas when sending out relevant information following an event to likely affected property owners. And you can also use the BLE data to identify areas that will likely require damage assessment, areas that are at high chance of needing debris removal, and areas that you would need to collect high water marks. Lastly, the BLE data can be used for long-term resilience to determine if a structure that was located within a high-risk area will be rebuilt following an event, and if it will need to be relocated or elevated. And we can also use the BLE data to estimate BFEs so that you can receive permit repairs for substantially damaged buildings. So that is all that I have for you regarding BLE data use within emergency management. So I'm going to pass the presentation back to Joe, and if you have any questions, feel free to ask them now.
Hey everybody, I'm back. I'll go through a couple slides and then we can take any answers or any questions you want. Go ahead and go to the next slide. This is the second of the two questions you need to answer. I'll talk a little louder in case you fell asleep. Make sure that you answer this question, and go ahead and answer this question, and we'll give a few minutes here for you to respond. Can base level engineering be used in support of a letter of MAP amendment submissions? Yes or no? And I can't see who's responding, Nick, so if you can.
Sorry, my team's froze.
Oh, bunch of yeses so far. And I'd hate to be the person who says no at this point. So I'll let you keep typing in. That's fine. Yes is the correct answer. You can use the BFE from that for Zone A areas, which is all we create the BLE for anyway, as Nick was talking about. And you can also use the LiDAR data set to come up with the lowest adjacent grade, like we discussed, with some caveats that it adds a little in. But that's good. So let's go on to the next slide. We're almost done. Promise. Next slide, Nick. Oh, so you saw a lot of stuff today, and there is absolutely no way you're going to remember all of it or even most of it if you don't use it every single day. Just the good thing about this workshop and the intent was just to give you an idea of exactly, an idea of what's out there and what it may be used for. As you get around to using it and you have questions, contact one of us here. You see the list there, resources. Again, I'm Joe. Contact any one of us on this under the mapping, my contractors. You can contact any of us and we will help you use the viewer and answer questions. It will not be a problem. I will stop here and just see if anybody has any questions at all they want to ask, or anything else they'd like to see again, or looking over here because I've got two screens. Sorry.
You can type your questions in the chat too.
Oh yeah. You can go ahead and well, let me say, while we're waiting for questions, thanks. I want to say thank you to Monica, and Nick, and Matt, and Lindsay for presenting this information. It was very well done. Thank you, and a special thanks to everybody who joined to look into this. We have spent a lot of money developing a lot of engineering, and we think it's very useful, and then we think you'll find it useful when the time comes. So okay. We got a question. So how soon in the future can we expect this data to be used in firm maps in the future? Well, we've started using this data for some of the areas we created BLE. Can somebody pull up that map for me? The one showing the status. Actually, that probably won't do any good. I don't have the list of exactly which ones, but wow. Does anybody ever know which ones we started?
Lindsay, maybe go to slide 5 that has the list of the watersheds.
Yes, that would be helpful. I'm trying to pull up my spreadsheet. I don't want to get it wrong. But while they're doing that, I will say, as funding becomes available from FEMA, we'll be doing more and more of these mappings. So
Lower Flint, Nick? Was it lower or middle?
I'm pulling up my spreadsheet now. I'm sorry. I should have had this ready. That's such an obvious question. Give me 1 second. I apologize. I won't. Well, listen, if you're not interested in hearing answers to questions or asking questions, feel free to hop on off. I don't want to keep you here any longer than I need to, but I am going to answer that question as soon as I pull up my tracking spreadsheet. Once again, I'm pulling up the spreadsheet. Okay, we have started mapping on the following watersheds. Let's see, Appalachia Bay, St. Mark's, Apalachicola, Osceola, Ichaway, Nochaway, Lower Chattahoochee, Lower Gluckney, and Spring watersheds. We have also doing the Upper Gluckney, Middle Flint, and Kinchafoodie Muckley. So if you're not familiar with the things, we're doing basically Grady, Thomas, Decatur, Brooks, Baker, Calhoun, Clay, Doherty, Early, Lee, Miller, Randolph, Stewart, Terrell, Webster, Seminole, Miller, Marion, Schley, Stewart, Sumter, Crisp, Dooley, Houston, Macon, Marion, Taylor, Turner, Worth, Colquitt. That's pretty much it. So pretty much those counties and those watersheds are the ones we have funding for and we're currently working on. Yeah, I see that 2009. That's why we started with the BLE in South Georgia, because everybody's maps are really old for the most part. And we wanted to get the engineering done. So then all we had to do is come back and ask for funding for the mapping. So we get the engineering out there that you can use in the ways in which we showed you, and then we can also start mapping. But if you have any questions specifically, just give me a call and I can take a look a little closer.
Right. And those projects that are being advanced into, creating regulatory maps, we actually contact the communities many times during the life of those projects. So you will hear from the DNR or one of us whenever that project is ongoing. So it won't just happen. Like, we will be calling you for sure.
Hope that answers your question. And I didn't mention Ware County, but I am. We're moving these. When I get this year's funding, we'll get more, and we go up. Yeah, using the BLE for reference. Yeah, that's absolutely right. The good news is you can use the floodplain boundaries and the BFEs in those Zone A areas for all your floodplain management. So if you got a project development, you need to come up with a BLE, obviously. Well, that BLE will be be associated with the floodplain that's also on the map. So you'll be able to clearly see what the floodplain should be, and you use both the floodplain and the BFE for floodplain management purposes. Any other questions? Okay, well, again, thank you. Give me a call if you have any questions or need any help, and I'll let everybody go. Thanks again for joining us today. Take care.